Hi everyone, welcome back to the series on production machine learning systems. In this video, we'll explore designing a newsfeed system, one of the most critical components in social media platforms like Facebook, Instagram, or Twitter. The newsfeed is that central, ever-updating list of content, posts, photos, links, and status updates from the people, pages, or topics you follow. It's personalized, dynamic, and needs to be incredibly responsive, even at massive scale. Our challenge is to design a system that can efficiently deliver relevant content to users in real time, handle high fan-out situations, like a celebrity post reaching millions, balance fast, read-write performance, and support billions of daily interactions, likes, comments, shares. This is a problem that sits at the intersection of systems design, caching strategy, data modeling, and user experience. We'll start by understanding the requirements, then propose a high-level architecture, and finally dive deep into how fan-out, caching, and feed construction work under the hood. Let's dive in. The problem is to design a newsfeed system. Newsfeed is the constantly updating list of stories in the middle of your Facebook or Twitter homepage. It includes updates, photos, links, pages from the people you follow. Here are some good requirement questions to ask. Is this a mobile app, a website, or both? What are the import features? How many friends can a user have? What's the traffic volume? In this slide, we'll look at the high-level design of a Facebook-style newsfeed system. Let's begin with the APIs. The Feed Publishing API is a post endpoint used by users to publish new posts. When a post is published, it gets saved in both the cache and the database to ensure quick access and persistence. The Retrieval API is a GET endpoint used to fetch a user's newsfeed. It first checks the cache for performance. If the data isn't in the cache, it falls back to the database. Next, we have the load balancer, which is essential for distributing incoming API requests across multiple web servers. This ensures the system can scale horizontally and handle large volumes of user traffic efficiently. Once a post is published, the fan-out service is responsible for pushing that post to the news feeds of the publisher's friends. We'll dive deeper into this fan-out logic in the next slide. We also integrate a notification service, which alerts friends about the newly published post. These notifications can be delivered through multiple channels like in-app alerts or emails, depending on the system's design and user preferences. This modular architecture helps achieve scalability, responsiveness, and user engagement in a real-time social platform. In this slide, we take a closer look at the architecture behind the newsfeed system, particularly how we scale for billions of users and post daily. Fan-out service. We start with the fan-out models. There are two main strategies. Fan-out on write, or the push model, pushes a newly published post to all friends' feeds as soon as it's published. This gives fast read performance but can be expensive for users with many followers. Fan-out on read, or the pull model, computes the feed on demand when a user loads their homepage. It saves work during writes, but increases read latency and system load. We typically use a hybrid approach. Apply fan-out on write for most users to ensure low latency, but switch to fan-out on read for celebrities or users with massive followings to avoid scalability issues. To mitigate the hotkey problem, where a popular user causes a high volume of requests for the same data, we employ consistent hashing to spread cache and storage loads evenly. Feed publishing. Workflow. When a user publishes a post, the system first fetches their friend list from a graph database. Then it filters the list based on user privacy settings and fetches additional info from the user cache. The filtered friend list and the new post ID are then sent to a message queue. Fan-out workers read from this queue and store each relevant post in a newsfeed cache, which maps post.id, user, ID pairs for efficient retrieval. Feed retrieval. Workflow. When a user requests their feed, the load balancer routes the request to an appropriate web server. The server invokes the Newsfeed service, which retrieves a list of post IDs from the Newsfeed cache. These post IDs are then hydrated with full content and metadata by fetching user and post objects from a dedicated content cache. The fully constructed feed is returned as a JSON payload to the client. We use caching extensively. Newsfeed cache stores post user mappings for fast access. Content cache keeps post text, media, etc. Social graph cache speeds up friend lookups. Action and counter caches help track likes, comments, and shares efficiently. Together, this design balances latency, throughput, and system scalability, key for supporting Facebook scale traffic.